Have you ever seen raisins dance? No, seriously, watch this. It's one of the coolest and easiest science experiments you can do right in your kitchen, and it reveals a powerful force of nature that's happening all around us. All you need is a clear glass, some clear fizzy soda like lemon lime or club soda, and a handful of raisins. Let's get started. First, pour the soda into the glass. Look at all those bubbles fizzing up. Each one is a tiny pocket of carbon dioxide gas escaping the liquid. Now for the magic part. Let's drop a few raisins in. What do you think will happen? Watch closely. At first, they sink straight to the bottom. That makes sense, right? Raisins are denser than the soda, so gravity pulls them down. But wait, what's happening now? See those tiny bubbles? They're starting to cling to the wrinkly surface of the raisins. It's like the raisins are gathering a crew of tiny, bubbly life rafts. As more and more bubbles attach, something amazing happens. The raisins start to rise, they're floating up to the surface. It's like they've suddenly become lighter. But how? This is a force called buoyancy in action. The combined lift of all those little gas bubbles is now strong enough to overcome the pull of gravity on the raisin. So up it goes, but the dance isn't over. Once the raisin reaches the surface, pop. The bubbles burst, releasing their gas into the air. Without its bubbly life preservers, the raisin is dense again, gravity takes over, and down it sinks. The cycle is complete, but it's about to start all over again. Once it's back at the bottom, new bubbles will start to gather on its surface. Soon, it'll have enough lift to float back to the top, up, down, up, down. The raisins are literally dancing in the glass, caught in a beautiful tug-of-war between gravity pulling them down and the buoyant force of the gas bubbles lifting them up. It's a continuous physics performance choreographed by nature itself. So why do the bubbles stick to the raisins in the first place? It's all about surface area and something called nucleation sites. A raisin's skin is wrinkly and rough, full of tiny nooks and crannies. These little imperfections are the perfect spots for dissolved carbon dioxide gas to collect and form bubbles. A smooth object, like a marble, wouldn't have nearly as many places for bubbles to grab onto, so it would just stay at the bottom. Now, let's turn this demonstration into a full-blown experiment. What happens if we change the variables? Science isn't just about watching things happen. It's about asking what if and testing our ideas. First, let's try different dancers. I have some other small items here. How about a piece of uncooked pasta, like a small shell or a piece of macaroni? It has some curves and hollows. Let's drop it in. Will it dance? It looks like bubbles are collecting on it too. And there it goes, slowly making its way to the surface. It seems the pasta is also a great dancer. What about something a little heavier, like a dried bean? Let's try a pinto bean. It sinks to the bottom. Bubbles are forming, but are there enough to lift it? It's trying. It might be a bit too dense, or its surface might be too smooth. This one seems to be a wallflower at our physics party. Let's try corn kernels. Dried popcorn kernels are interesting. They're small and have an irregular shape. Let's drop a few in. They sink ... and look, the bubbles love them. They're rising and sinking just like the raisins. We've discovered another fantastic dancer. This is the core of the scientific method: observation, hypothesis, and experimentation. We observed the raisins, hypothesized that their wrinkly surface was key, and then tested that hypothesis with different objects. We found that objects with rough or complex surfaces that are just the right density make the best dancers. Now, what about changing the liquid? All fizzy drinks have dissolved carbon dioxide, but do they all work the same? I have some seltzer water here and also a dark cola. Let's set up two more glasses, one with seltzer, one with cola. And we'll use our star performers, the raisins, in both. In the seltzer water, the raisins are dancing perfectly, just like before. The action is clear and easy to see. Now for the cola, we drop them in. It's a bit harder to see, but yes, they're moving up and down. It seems the type of soda doesn't stop the dance, as long as it's carbonated. The dance is universal for fizzy drinks. This principle of buoyancy isn't just for kitchen experiments. It's a fundamental force of physics. It's why huge steel ships, which are way denser than water, can float. Their shape displaces a massive amount of water, creating an upward buoyant force that's strong enough to support their weight. It's the same reason a hot air balloon rises. The hot air inside the balloon is less dense than the cooler air outside it, creating lift. Our dancing raisins are just a miniature, simplified version of these same powerful principles. You can even take this experiment further. What happens if you use warm soda versus cold soda? Gas is less soluble in warmer liquids, meaning the bubbles might form faster. Would the raisins dance faster, or would the soda go flat too quickly for them to dance at all? What if you tried different kinds of raisins, golden raisins versus regular ones? Or what about a different dried fruit, like a small piece of dried cranberry? Each one has a different density and surface texture. Which one do you predict would be the best dancer? You have now become a science choreographer. By choosing your dancers and your stage, you can create a unique physics performance every single time. It's a fun, visual way to understand complex ideas like density, gravity, and buoyancy. Plus, it looks really, really cool. So next time you have some soda and raisins, don't just have a snack, put on a show. A show that demonstrates the beautiful, invisible forces that shape our world. It's a simple reminder that science is everywhere, even in a glass of soda. It's curious, it's fun, and it's something you can discover for yourself. Thanks for watching and experimenting with me today. Give this a try at home and let me know in the comments which objects you found that can dance. Don't forget to like this video and subscribe for more fun science you can do yourself. See you next time.